Hello friends, welcome to my YouTube channel Aviator Updates. I am Rakesh Negi and I am an aviation enthusiast. Today I am going to discuss about Superheterodyne receiver. Okay, so I'll write down the topic name. So it's Superheterodyne receiver. So super heterodyne receiver. So in modern day, this is the most preferable receiver. We should know that friends, AM receivers or amplitude modulated receivers are of two types. One is straight radio receiver and the other one is super heterodyne receiver. Amongst these two radio receiver friends, the straight radio receiver is not preferable. Why? It's because it produces too much of interference of the adjacent broadcast station. That's why super heterodyne receiver was invented, and this was invented by Major Edwin H. Armstrong during the First World War. Okay, so let's not waste the time and let's start the topic. For the super heterodyne receiver to process the signal, first of all it should receive the signal, and we know well friends, the signals are transmitted from the broadcasting stations. So those broadcasting stations, when they transmit the frequencies, okay, for them to be received, an antenna should be there or aerial should be there. Suppose this is the aerial, okay, and these are the broadcasting signals which are coming. So this antenna will receive this signal and it will give this signal to a radio frequency amplifier, or we can say RF amplifier. This RF amplifier is a tuned parallel circuit of capacitor and inductor, which we'll learn ahead. So what happens is, from the broadcasting stations the antenna will receive the signal and this is given to the RF amplifier. Amongst all the RF waves received, this will select one of the radio frequency and it will reject the other. So this amplifier receives the radio frequency, and suppose that frequency is F1. Okay, next, within the super heterodyne receiver there is a local oscillator. Which produces a high frequency, and that frequency, suppose it's F2. Okay, now both these frequencies F1 and F2, F1 is the RF radio frequency and F2 is the high frequency which is produced by the local oscillator. Now both of these frequencies are given to a unit called as mixer circuit. Okay, now this mixer circuit, what does it do? It used to produce a frequency called as IF frequency, that is the intermediate frequency, which is of 455 kilohertz. Okay friends, so remember that this 455 kilohertz frequency is a fixed frequency. I mean to say, the mixer circuit will always produce 455 kilohertz and will not produce any frequency above or below 455 kilohertz. Okay friends, so this 455 kilohertz is a lower frequency. Let me quickly summarize what we have discussed. From the broadcasting stations, the signal is received by the antenna and then it is given to the RF amplifier. The RF amplifier then selects a particular radio frequency to which it is tuned, and then that frequency is here as F1. Now within the super heterodyne receiver there is a local oscillator which produces a high frequency, that is F2. Both of these frequencies are combined in the mixer circuit, or simply mixer you can say, and then this mixer circuit produces a frequency which is a lower frequency called as IF, that is the intermediate frequency, which is 455 kilohertz, which is a fixed frequency. Okay friends, so here you should know that friends, why we always get 455 kilohertz. It's because the circuit is so designed that the oscillator always produces a frequency 455 kilohertz above the selected frequency of the radio frequency amplifier. Hence the mixer will always produce 455 kilohertz as the intermediate frequency, regardless of the frequency to which the receiver is tuned. For example, there is a broadcast station which is transmitting at 600 kilohertz, and the receiver also has been tuned to 600 kilohertz, then in that case 600 kilohertz will be received by this radio frequency amplifier. Okay, that will be F1. In this situation, what will be the oscillator frequency? The oscillator frequency will be 455 ahead of this, that is 1055 kilohertz. Are you getting, friends? So as I have told earlier, a local oscillator produces a frequency which is 455 kilohertz above the selected frequency. Okay, that's why here in this case the local oscillator is producing 1055 kilohertz. And if you see how much greater 1055 kilohertz is from 600 kilohertz, 455. Okay, so that's why when both these frequencies go to the mixer unit will produce 455 kilohertz, that is 1055 minus 600. Okay, both are in kilohertz, we get 455 kilohertz. Hence the mixer always produces a fixed frequency, that is 455 kilohertz, which is a low frequency. That means in super heterodyne receiver, the high frequency, that is the radio frequency, is converted to a lower frequency, okay, by the mixer unit. So as we know, 455 kilohertz has been produced by the mixer unit. So this is a salient feature of super heterodyne receiver. Okay friends, I repeat again, we should know that the salient feature of super heterodyne receiver is to produce 455 kilohertz. That is the intermediate frequency. So at this intermediate frequency, which is a lower frequency, the amplifier circuits operate at maximum stability, selectivity and sensitivity. Okay friends, that is the advantage of having lower frequency. So what happened in this? A high frequency came in from here and it was converted to a lower frequency, and this frequency is called as the heterodyne signal, and the process is called as the heterodyning. Hence the name of this receiver is super heterodyne receiver. Now let's discuss in detail all the stages of a super heterodyne receiver. Okay, I have given you the basic idea. So there are broadcasting stations which are transmitting the signal, and there is an antenna. So this antenna receives the signal, we can say aerial also. So this aerial receives the signal and gives it to the radio frequency amplifier, which I have told you is a parallel tuned circuit where capacitor and inductor are there. Remember that friends, here we have variable capacitors. Okay, so suppose this is one of the variable capacitor, this is the inductor. So this is RF amplifier circuit. So here we get F1, right, frequency, that is the F1. Now this is one of the source. The other source is the local oscillator, which I have told you, which is there within the super heterodyne receiver. So that local oscillator also is a tuned parallel circuit. Okay, here also we have a capacitor and inductor. Okay, and also we have mixer unit, that is also a tuned parallel circuit. Why I am saying parallel circuit, friends, is because there is a capacitor and inductor connected in parallel. This is also a variable capacitor. Okay, so from the oscillator, the frequency is given to the mixer unit. So this is the mixer circuit, or you can simply say it as mixer. So what is this? This is the RF amplifier. Okay friends, so from the RF amplifier, F1, that is the frequency, is given to mixer circuit. From the local oscillator frequency, suppose that is the F2, is given to the mixer circuit. So now what we get? We get IF, that is the intermediate frequency, right? So that intermediate frequency is of 455 kilohertz. That's what we have studied. Okay, now I'll just rename these capacitors. Okay friends, suppose this capacitor is C1, this is C2, and suppose this is C3, this capacitor. Likewise here this inductor is L1, this is L2, and this is L3. Okay, so we have these circuits. Now note that friends, all these three capacitors C1, C2 and C3, they are connected together to a single rod. Okay, if we rotate that rod, then the capacitance will vary. Okay, so I'll just draw a dotted line like this from the capacitors. Okay, so I have drawn these dotted lines to tell you that all these three capacitors are connected together, so that if we are varying the capacitance in all the three circuits, the capacitance value will vary. Okay, these are called as gang capacitors. What are they called? Gang capacitors. Why? Because they are connected in a group or in a gang, hence the name gang capacitors. Now the circuit is designed such that this local oscillator will always produce a frequency which is higher than the selected frequency, which is F1, that is the radio frequency, by how much? 455 kilohertz. So note that if the local oscillator has to produce a higher frequency compared to the F1, that is the radio frequency, then what is important is the capacitor, the variable capacitance C3 should be lesser than C1 and C2. Why? Because we know well friends, the capacitance is inversely proportional to frequency. We know well friends, XC is equal to 1 upon 2 pi FC, right? That means frequency is inversely proportional to capacitance, right? Okay, so frequency is inversely proportional to capacitance. So whenever you decrease the capacitance, the frequency will increase. So that's why for this local oscillator to produce a higher frequency compared to this RF frequency, it has to have its capacitance value lesser. Okay, so that's why whenever we are changing the variable capacitance by a single rod, by rotating it, the capacitance values are changed in such a way that C1 and C2 are greater than the C3. Okay, next we have seen that a signal is received, given to the RF amplifier, and also the signal comes from, or the high frequency comes from, local oscillator and given to the mixer circuit. Now from the mixer circuit we get IF. This IF, intermediate frequency, is given to IF amplifier. What does the IF amplifier do? The IF amplifier will amplify the intermediate frequency. So once it amplifies, this signal will be given to a unit called as detector. So this detector, what does it do? It used to collect the output from the last stage of the IF amplifier. There may not be just one IF amplifier, but there can be amplifiers. So from the last stage of the IF amplifiers, this detector extract the audio frequency and it will give that signal to AF amplifier. Okay friends, so what does the detector do? It extracts the audio frequency signal and gives it to the audio amplifier. Okay, let's just pause this topic. The signal which is received consists of two parts, RF and AF. Both are combined together. So RF is the carrier which assists in carrying the information signal from source to the destination, that is the receiver, and AF is the actual signal which you want to have, okay, which is carrying the information. So now the detector used to segregate both of them. It just extracts the AF, that is the information part, and then this amplifier will amplify the AF signal to such a level that it can be given to the speaker. So this is the speaker. So this speaker, what does it do? Speaker used to produce the audio signal in the form of sound waves, which are more powerful as it was there in the broadcasting station. So hence we get the information or the audio from the speaker. So these are the stages of super heterodyne receiver. Here what we have studied that the super heterodyne receiver does the process of heterodyning. Now what is this heterodyning? Whenever a high frequency signal is mixed with another signal, when we combine a high frequency signal which is from the oscillator with the RF in a mixer unit, it produces a heterodyne signal, and the process is called as heterodyning. Okay, hence the name of the receiver is heterodyne receiver. Now let me just summarize the topic, friends. What we have studied: from the broadcast station the signal is transmitted and that will be received by this antenna, and those radio waves which are received by this antenna will be given to this radio frequency amplifier. Now this radio frequency amplifier, it used to select only that particular frequency to which the receiver is tuned. After receiving that frequency suppose is F1. Now at the same time there is a local oscillator within the superheterodyne receiver which also produces a higher frequency. How much frequency? Which is above this F1 frequency by how much? By 455 kilohertz. Okay. So for that we have taken the example. So if the RF frequency is 600 kilohertz, then the oscillator will produce 1055 kilohertz, and both of these signals when given to the mixer circuit or mixer will produce an intermediate frequency which is a fixed frequency, which will always be 455 kilohertz. It is a lower frequency and called as the heterodyne signal. Okay, hence the name of the receiver is heterodyne receiver. Next, after that we have studied about the stages in detail of the superheterodyne receiver, where we studied that the signal which is received by the aerial is given to an RF amplifier. The RF amplifier is a parallel tuned circuit as like the mixer circuit and the local oscillator. In these parallel tuned circuits, what is common is the gang capacitor. Okay, C1, C2 and C3 are the capacitors which are connected together, hence called as the gang capacitors. Even if we vary this, the circuit will still produce 455 kilohertz as the intermediate frequency. This intermediate frequency is a lower frequency compared to the radio frequency. Now this intermediate frequency is given to the IF amplifier which will amplify this frequency, and after amplification of the intermediate frequency it is given to a detector unit. The detector, what does it do? It used to extract the audio signal from the radio frequency. Audio signal is the signal which carries the information which you want to hear in the speaker. So that audio signal is then given to an amplifier which is the AF. AF is the audio frequency amplifier. Why audio frequency? Why not radio frequency here? Is because now the detector has extracted the audio frequency signal from the last stage of the IF amplifier and then given to the AF amplifier. The AF amplifier will amplify the signal to a certain level suitable to be given to the loudspeaker. Then the loudspeaker used to produce the audio in the form of sound waves, and these will be of a particular strength which will be equivalent to the sound as was transmitted from the broadcasting stations. So this is all about the super heterodyne receiver. So friends, I hope you have understood the principle of super heterodyne receiver. I'll come up again with a new topic in my next session. Till then, enjoy learning and thank you.